tired there in a hurry and looking outside right now. Well, there's me, but let me see. Outside cam, there we go. Pretty much clear, and we've got 80 degrees, which is still up there in terms of temperature, but the air is fairly dry right now. And I figure I'll show you this chart here. That's not the outside current chart right now, but that is a significant chart in other respects because this is for August 3rd of 1985 when Delta 191 crashed at DFW Airport, and this is showing the prevailing conditions we had on that date. And you can see some pretty good moisture out in East Texas with a bit of easterly flow. And by looking at the streamlines, you can see a little bit of convergence there in East Texas. Maybe along this axis right there. The satellite picture at the time looked like this. And this is showing the DFW area. The airport is located right there. And I think the crash here was about... Oh, okay. Hang on a second. This is for August 2nd. You know, when I did this, I must have pulled down the wrong chart from the server. Let me make sure I'm not having a senior moment. Okay, that was August 2nd. That was yesterday. However, dang, we'll continue looking at this anyway. So August 2nd is actually the date, and I'm thinking of something else. And yeah, you know what's keying me in on this. August 3rd, that's the date I arrived in the Philippines many years ago, so I'm remembering that anniversary. However, yeah, this is definitely the satellite imagery for the time. And let me pull up the actual surface data and get that straightened out. Go into digital atmosphere. We're going to see kind of a similar pattern, I suspect. And there it is. I think the temperatures, however, will be a little hotter at DFW Airport. In fact, they had a thunderstorm going at the time. So let me back that up a few more hours. So again, we're looking at 1985 for yesterday, the date of the anniversary on the Delta 191 crash. And there you go. You can see the 101 degree temperatures. In fact, looks like some sort of backdoor front here. A little bit more of a push. Almost all the way to DFW right there. Cooler temperatures back behind that boundary. And you can see 101 there at Lufkin, 101 at Waco, and also DFW Airport. Now, I figure I'll show you this. I don't know how many of you actually seen the CVR, the transcript. This is the actual Wikipedia page for the crash. 137 fatalities in that, but fortunately there were 27 survivors. It's not much, but at least it's something. And what had happened, I'll just kind of give you the rundown here. Sorry about that. Had something stuck between my teeth there. I'm trying to figure out what's going on. Okay. Okay, apologize for that. All done. Okay, here's the DFW airport layout. And for some reason, on the internet, I cannot find airport diagrams for 85. The runway patterns were different. This did not exist, and the runways were a little bit shorter. Like all this didn't exist. But anyway, the aircraft was arriving from the north on the northeast side of the airport, heading this way, and there happened to be a microburst over the airfield. The aircraft encountered that, encountered the very strong headwinds on the approach right here, so they throttled it back. And then as they emerged on the other side close to touchdown, they got the tailwinds and they lost lift, and the aircraft settled down at a very high rate just short of the threshold. And I'm going to show you this transcript, and if this is a little disturbing, you might want to wait a minute before playing this, but anyway, this will kind of show you the sequence of events. This is a National Transportation Safety Board reconstruction here. So here we go. This is going to run about 1 minute. And keep an eye. What you want to watch is the airspeed here. This is what the airspeed was seeing. So lower values are going to be over here. That's like a loss of lift in airspeed. EPR or EPR, that's the thrust setting on the aircraft, 3 engines. And this here is just the estimated wind vector. So I'm going to go ahead and run this.
Yes, sir. Everybody around the corner when you're number 1. Major 156, contact.
You're going to lose it all of a sudden. There it is. Push it up. Push it way up. Way up. Way up. Way up. That's it.
Hang on.
So you can see the throttling up, and that's what happened there. Very prominent encounter with a microburst there, and there was a whole lot of focus by the FAA and the Weather Service on microburst detection that resulted in the installation of the TWR radars in the 90s and accelerated the WSR-88D program, and fortunately now we have some very good tools. So that's the Delta 1 incident, and shows you how quickly those that loss of airspeed can creep up on you. And probably at the time, the best thing would have been to go around. Let me show you this one very interesting thing about that. I'm going to show you the meteor observations. This is the actual meteor observations in sequence. So you can see earlier in the morning, we started out like in the 70s, pretty average, a little bit of high middle cloud, 8,000 foot altocumulus. Look at those nice remarks, flockus, all quads, indicating instability. They're actually referring to a kind of altocumulus castellanus, which means there's some instability aloft there. Okay, then as the afternoon went on, there's the key observations right there, and look at that right there. 50 knots, gusting to 70 knots there at DFW, winds out of 300, which is northwest, obscured and overcast, thunderstorms with rain, and thunderstorms north through northeast of the airfield. So that's kind of a critical thing, the storms being just north of the airfield, which means the airplane cut right through the core on that southward approach. And you can see as rapidly as the storm stopped, we were back down to 7 to 10 knots. And a couple hours later, it's almost like nothing happened. Okay, let's go ahead and move on to today's weather. In fact, let me just go ahead and clear those windows out. Okay, so that'll give me a little bit of breathing room here to get through the rest of the webcast. We've got a much different picture here in Texas, and we're kind of under the influence of kind of a large ridge. Very weak ridge, high pressure. That's what has pushed the front down into the Gulf of Mexico. So we've got a very stagnant weather pattern. However, a new front coming in from the north, there it is right there. And maybe if I plot those little deformation products, you can see the leading edge of that. Yeah, right there. A little bit of outflow boundary, and there's that line. Next front coming down, and let's see what the wind field or the moisture field looks like ahead of that. You can see most of the moisture concentrated in Arkansas and Louisiana. 72-degree dew points, and then our 68-degree isodrosotherm along Interstate 35, and then much drier air out in the Texas Panhandle and West Texas. So where's the best place for initiation? We can look at theta E. That's always the best product. And that's assuming the upper level conditions are the same across an area. Storms are always going to favor the high theta E air. And it's a very noisy field because we're combining dew point and temperature, and to a certain extent altitude there. But what we're looking at, just kind of filter through this and find the large scale patterns. And when we do that, we see kind of a ridge right there. And maybe a little bit of a pool right here. So this would kind of outline a theta E max. And then there would be another one up here, right there. And this probably extends up a little bit further, so there is support for these storms right here. And if there's inflow in the lower levels, 925, 850, that could keep those storms going a little bit further into the nighttime hours. Let's see, elsewhere around the country, we've got storms all over the place. I mean, there's no way we can cover all of these. One little MCS going through the Michigan area, coming through Chicago, and that one we can cover. I've got some radar data going for that. And there's the Chicago radar. Looks a little bit disorganized, but if we zoom down in there, we can see a little bit of a bow echo structure. So possibly a little bit of maybe locally enhanced winds on a few of these cells, but no strong reflectivity gradients. And there's a lot of cell competition. Looks like a relatively uncapped air mass. Cells pretty much all over the place. All right, let me take a look at the chat and make sure that our audio is good. I tried to double check everything here. Andrew saying some storms passed through Peoria, Illinois. Peoria. Yeah, please. Yesterday, if any of you guys told me your location and wanted to share that with me, please do that again. I accidentally closed the window, but I want to capture those locations again so I can put them in my notes here. Looking forward to the cool down in Peoria as the front passes. Sue M. in Indiana saying the storms are going northeast of her. Bummer. Ryan is checking in, and Davis here. Burning hot, 103 heat index where Ryan is with a string of Sahara dust. So Ryan there reporting dust in Florida. Let's see, where is the dust product? Here it comes. Oh, come on, NASA. I had all this queued up here. I had the optical depth all loaded up. I guess she doesn't want to plot. Okay, let me try to plotting the Suomi. Okay, I don't know what's going on with that side. I'll just let it sit there for a while. Burl H. saying a nice breeze with cooler, drier air after a frontal passage in east central Iowa. And Ryan saying a strong Sahara dust cloud remaining over South Florida into Saturday evening. I'm just going to reload that worldview site. I'm starting to wonder if their site is broken here. Yeah, I'm not getting any products. I'm going to just let that do whatever it's doing and switch over to the visible imagery. And we can see some of those storms there in the Midwest. Eddie W. is here, and Fun with Tech. David Holcomb is here. TD, monsoon weather in California. Michael Burrell thanking me for the eclipse detail upload. So yeah, go back and check that out if some of you haven't seen that. Little 45-minute perspective on the upcoming eclipse weather. David Moore says, ditto what Michael said. Thank you. TD is planning on driving up the I-5 to Oregon for the eclipse, fully stocked with extra fuel, water, and food. Yeah, very smart there. Have Ron Chalfant here. Sue M. tried to order eclipse glasses on Amazon. None will get here in time. One vendor wanted $70. Wow. Good grief. I guess if I had bought up in a bunch of eclipse glasses back in 2011, I could have been rich here. Ryan will be driving up to Asheville on August 18th to stay with family in the eclipse zone. David Moore was driving on the west side of DFW Airport back in '85 for that Delta 191 storm. Storms blew up very rapidly that afternoon. I wonder if I can look at the skew-T for Stephenville on that day. Let me try to do that real quick. I'm going to import the upper air data. And the better moisture, I think Longview is going to be a little bit more representative. So let me plot that. Data, soundings. And there it is, Longview. Okay. I can see a few problems in the data here, but oh, this is great. I can't scroll it up. Let me try to regenerate this diagram just a little bit too big to fit in the window. That's a little bit too small. And that's much better. Okay, what we see here on the, this is 1985. This is within about an hour of that Flight 191 crash. This was about 100 miles east-southeast of DFW. And what we see here, pretty steep lapse rate. Now, what's important is we have to modify the sounding, because you can see here in the lower levels, the temperatures are in the low 80s, so they've had thunderstorm activity there in the Longview area. But the upper level parts of the sounding are likely to be fairly representative. So if we take that 100-degree temperature, that's going to be about 38 degrees Celsius. We can immediately just plot that up like this. Then the question is, what kind of moisture do we have? I'm thinking maybe some 69 to 70 degree dew points might have been present there at the time. So we start with about 70, and we go up the mixing ratio lines like that. In fact, it might have been a little bit weaker. I might have been overestimating this. But there's the parcel lift, and we can see a whole lot of cape there. All that is cape. And eyeballing that, that's probably about 2,000, 2,500. And even more importantly, we have this kind of a little bit of an inverted V sounding. Wet bulb temperatures are going to be in the low to mid 70s, which means some good downburst potential with those storms. So definitely a good sounding here for thunderstorms if you have 101 degree temperatures. Go back to the Chicago radar there. Eddie W. says, Lowe's Stores has the glasses for sale. You can get a welding mask for cheaper. Amazon glasses were $2, but $70 to ship. Yeah, that's kind of a ripoff there. TD asking about the Delta 191 crash. Yeah, that was a Lockheed L-1011 wide body that crashed there at DFW Airport on August 2nd in 1985. About 130 people died, about 25 survivors or so. They should have hit the throttle up and continued on. Yeah, the pilot was trying to put that airplane down on the ground and figured he could just use the radar and his quick reflexes to land the aircraft. David Moore says 15 to 20 minutes before the crash, there was no indication of storms that day. Mike Estwick joining us. Lonely cell near the airport that day. And the training wasn't there either. Those L-1011s and DC-10s were tough birds to fly from Ryan. And I'm going to have to kind of skip through the rest of the comments to kind of keep us moving along. Got Dave there in Calgary. Low 70s in Denver. Nice low 70s where Mike is. Naperville, one of the storms rolled into the area. Manchys, new name there. 30 degrees Celsius, heavy particles at 6 p.m. John Booma saying to get a welder's helmet. The particulation is so bad where Manchys is his smoke alarm is going off. Where are you located? I'm guessing you must be up in the Northwest somewhere. Okay, and Ryan owns and operates a ground transportation service company for the airlines in South Florida. Okay, let's move things along here. There's the storms there in Illinois. Slightly disorganized there and maybe just a few isolated cells. All right, you can see a definite difference in the cloud cover as you go into the northern plains. Northerly flow coming down from Canada. Cumulus formed up into cloud streets with that unstable modifying air mass there. And then up in the Great Lakes area, we've got the next baroclinic system right there. You can kind of see the comet cloud there. This is going to show up a lot better on infrared. In fact, I can just pull that up right now. Okay, let's see here. There's the comet cloud right there over the Great Lakes. Yeah, we could do a little mini-me. I forgot about that. You can stick that on for just a little bit. But yeah, you can see the comet cloud. You have the deformation zone in the backside. And by deformation zone, we mean that first we got to consider that we have prevailing westerlies coming through here. But this system kind of disrupts that with the cyclonic circulation like that. So what you actually see is when you kind of plot out the winds, you'll get a wind pattern kind of like this on the back side. So right here, low pressure area, cold front and all that back in here, warm front right there. And then on the north side, you have this easterly flow coming over and hitting the westerly winds on the other side. So the air has to diverge on either side on that backside right there. So that little characteristic pattern you've probably seen in textbooks, that's the deformation zone. So we consider this to be the deformation zone cloud layer on the backside. Then we have the main baroclinic leaf itself, located right there. Not very well developed because, you know, it's summertime. And this little area where it's kind of triangulated through here like that, that's associated with the warm air advection in that area right there. So we're going to see that on the thickness chart when we take a look at that. We're going to see some trace, I think, of the warm front in this area. And then anything back up in the Great Lakes, that's going to be a occluded front. And And what happened to all that dry air? Where did that go? Well, it looks like it ended up in southern Louisiana. Remember yesterday it was way up in Dallas, and now it's just kind of wandering southeastward and probably going to make it into Florida or Georgia the next day or so. Let me zoom out on that real quick. And when we take a look at the water vapor imagery, one thing that we're kind of looking for is those classic S shapes, and you can see an S shape right here. So that might indicate something going on there in Alabama and Georgia. Possibly a short wave kind of in this area. So we're going to kind of keep an eye out for that. And then it looks like we've got some more weather there in California. A little bit of dry air moving in. Dry air with those thunderstorms there that might augment the downburst potential on those cells. Okay, potential temperature map. We can take a brief look at that. You can see the next front coming through Oklahoma and Colorado right there. Enhanced theta gradient right there. And some very cool air up in the Great Lakes right there. Okay, the frontal boundary. Very easy to find that cold front right there in the Great Plains. And then the warm front, that's a little bit harder to find, but there's some troughing right there around Detroit. And looks like that connects into the storm system right there. So there's the warm front. There's the cold front. Here's the high coming back in through the Dakotas. And then down in the Gulf is that graveyard for frontal systems. So everything is like moving very slowly this time of year. I think the systems are only making about a few hundred miles of progress every day. So we'll go ahead and head into the forecast. I think, there's not a whole lot going on except for afternoon cells here and there. Yeah, I guess we'll start out taking a look at things in the Great Plains. Let me zoom this out. Here's the mesoscale forecast and some storms up there in the Texas Panhandle. Looks like overnight those are going to move southeast. And the trend is for those to dissipate after midnight. So those will start falling apart there in the Midland area. And a few weak cells there in northern Oklahoma, but mostly going to be dominated by this high pressure area in Nebraska and Kansas. And the other story is going to be that cold front pushing southward. That's going to show up better on the wind field analysis here. So going to the very beginning, the current chart, you can see the leading edge of the front right there. Then by 12Z, 6 in the morning, you can see the leading edge coming up on Memphis, Little Rock, the Red River, and Lubbock. And then by afternoon, we're going to start thinking about possible initiation. Where did that front go? Well, earlier in the morning, it was right there. And I think by evening, probably pushing into northern Mississippi and almost to Dallas right there. And then the increased southerly flow in the high plains, bringing that boundary back northward like that. And there's the high pressure in Missouri, kind of helping that front to keep moving along. And then further out in the eastern U.S., there's the front right there. I guess we've got a little bit of new baroclinic development right there in Virginia. And then this is the old occluding low. All right, then we head into the weekend, another weekend, and I'm hoping to get some burgers on the grill or something like that. For Saturday night, strong cyclogenesis in the high plains, especially right there around Goodland. and that brings the moisture very rapidly to the north, up the I-35 corridor. And I guess that means that boundary is going to start retreating back northward. For Sunday, looks like we get a new front coming down, kind of driven by this 1030 millibar high. So here comes another front coming south towards Texas. For Monday, very good high pressure area, and we also have to consider the extent of the high pressure area. And we can do that just by drawing out some of the isobars, and that gives us an idea of the shape. And we can see the leading edge of that boundary, something like that. And very strong pressure gradients in the Lubbock area. And probably some good upslopes, so chance for some good high base storms in that area on Monday. And then for Tuesday, all this high pressure in the Midwest driving the front southward. Illinois, Indiana, Michigan, Dakotas, Minnesota, all those guys getting the benefit of the drier, cooler air, but too much modification really to get the benefits in the southern U.S. Maybe a little bit of dry air, and that's about it. And maybe some rain here and there. And likewise, this boundary will probably end up stalling in the south somewhere like that around Wednesday, Thursday. And then we get to the end of the run. I guess for some reason, pivotal weather is not doing the GFS past 172 hours, 174. Wonder what the reason for that is. But, you know, there are other sources of data, so I think as soon as the eclipse starts coming within view of the GFS, we're going to start looking at that information, but that's still several days off. Okay, one last look at chat, and let me give you something interesting to look at. What would be interesting? Let me go over to the SPC page. We've got no watches in effect, no mesoscale discussions. A few storm reports of wind here and there across the U.S. I think we'll take a look at Lubbock real quick. Okay, Lubbock radar coming up, and while that's loading, let me load up the chat. A lot of discussion here. Man, she's definitely needing rain. He's in BC. Thomas Copeland, he says welcome, or he says good evening all and late to the party. Mike Bexley is here. Ryan Toomey says the tropical wave moving off the west coast of Africa looks promising for development, moving westerly in between the Sahara dust layers. Yeah, we were looking at some sort of vortex out there on one of the GFS panels. There's that wave right there on the SPC site or the NHC site, 40% chance of development, and there it is. And this is a look at the streamlines. Hopefully this doesn't bog the stream down too much. I'm loading some GFS data, but you can see the closed circulation right there where that wave is, and there it goes. And taking a little bit of a northerly track, so that's probably going to go north of Puerto Rico. I'm going to load up the panel for the Atlantic. trying to do this manually so it doesn't kill the stream. And I guess that's not going to work. Part of the problem is they're not putting out the extended outlooks. But anyway, they were bringing this wave north of Puerto Rico and up to Florida. And maybe I can bring this up on the GFS side. Maybe I need to start using another site for the longer range stuff. So model guidance, North America, GFS. Okay, there's our storm right there, just north of the Bahamas. This is going to be on the 13th. And going out a little bit further to 300 hours. They've got that effect in New York on the 8th or 16th, and then in between, at the 264-hour point, they've got the storm. Yep, affecting the Carolinas. So that's starting to look like maybe affecting, maybe kind of running a path like that. But, you know, this is pretty far out, so there's a lot of variability. We could see the system even coming across Cuba and the Dominica, or maybe recurving further to the north. So all we can do at this point is just wait, and maybe in several days we'll have a good idea of the timing for the storm and the weather for the eclipse. Okay. I think that's about all I have for right now. I appreciate you all watching the webcast, and hopefully we'll see you all tomorrow. Whoa, sorry about that. Probably getting a little bit of feedback. Anyway, that's about all I got for tonight. Take care, and we will see you then. Have a good evening.